and thank you for tuning in. Welcome to a new episode of the Passion for Technology podcast by EBV Electronic.
Welcome to the Passion for Technology podcast. The speed at which electric vehicles can be charged is an important point of difference in the rapidly developing electric vehicle market. But the charging infrastructure has to keep up too, and the leaps in fast charging technology are just as significant. While 50 kilowatts charging stations were considered to be state-of-the-art until recently, we are now increasingly seeing stations installed that can charge EV batteries at 100, 150, or even 300 kilowatts. On today's show, we'll be discussing what this means for charging station technology with Sarah Gaimi. She's the Director of Technical Development at Avnet Abacus. Hi, Sarah.
Hi, Mustafa. It's a pleasure to be here today.
Likewise, my pleasure. Sarah, how important are fast charging stations for the success of electric vehicles?
Well, of course, fast charging stations are one of the essential elements in EV charging infrastructure. What counts more is having the right mix of various charging points like level 1, level 2, AC public stations, and fast charging stations. It is not just about using fast charging stations as a replacement for traditional gas stations today. The massive implementation of EVs need mindset change. For example, if we take a look at the statistics, 80% of daily driving is done on short distances. The average drive to work and back in Germany, for example, is about 32 kilometers long. Even if we double this number, with practically every electric car having an actual range of at least 100 kilometers, home charging can satisfy the need of the vast majority of the users. So the answer is yes, important, but also there are other elements in the infrastructure of EV chargings that they are very important to consider.
Sarah, the first 300 kilowatts charging stations are being actively deployed, and the first EV hypercars, such as the Lotus Evija, are even designed for 800 kilowatt of charging power. How do you see things developing?
Well, the first question is why we are moving toward high-power charging systems. There are three main advantages of high-power systems. One of them is the high efficiency. Second is the low charging time they are offering. And the third is low thermal losses they offer. We have tough goals to reduce the CO2 emissions in the transportation sector in Europe and, of course, worldwide. High power and high voltage solutions are required in order to accelerate the sales of EVs, get rid of course, range anxiety, and they are a big help to obtain higher efficiency of the whole infrastructure and offer affordable solutions for everyone involved in the EV charging infrastructure. So moving toward high power, high voltage is definitely the right direction to move toward.
So, Sarah, that sounds very sensible, but what are the major challenges in building these fast charging stations?
I would name three major challenges that the industry is facing with. One of them is, of course, the thermal management solution, because the higher the power and the higher the voltage in the system, we are facing with the higher current that they are producing a lot of heat on the charging station side. So it is a big challenge to face with. The other side of the story, which is the second major challenge, is the battery technology gap. They call it in the market like kind of lithium plating or aging. So having these high power charging stations and charging the batteries very often and frequently will lead to the battery aging, which is something we need to take into consideration. And the other, of course, which is going to be the third challenge, is the intensive CapEx. So they are building up and operating of EV fast charging stations are really CapEx intensive. There are a lot of costs on the equipment building, development of the EV charging stations, and of course, operation of these EV charging stations, which need to be considered in the whole infrastructure.
Sarah, cables and connectors might seem somewhat, let's say, mundane, but I think they're important in this, right? I mean, can you explain the importance of these components for fast charging applications?
Well, I would say that the main limitation of increasing the power capacity of charging stations is the cooling technology of the cables. So we have higher charging currents cause higher heating and stress on the connectors and the cable materials we have. So according to some existing standards, for secure use of EV charging stations, there are limited temperature rises allowed on the connector and cable side. Today, we have 200 amps limit on the cables in use. In order to increase this to 500 amps, there are specific cooling technologies in place to enable the pass of higher current without damaging the material. So there are a lot of cable companies working on the fluid-cooled cable or liquid-to-vapor cooling system, and a lot of new emerging technologies to bring the cooling technology to the cable and enable them to pass the high current, let's say, which is one of the consequences of having ultra-fast charging stations in the network.
Sarah, what solutions does Avnet Abacus offer to address some of those challenges?
Well, Avnet Abacus offers a lot of components from the passive parts to the cable and connectors, and also power components which are required for building up the EV charging stations. Together also with our partners, we provide an end-to-end solution. So it is not just about the component and modules. We are offering also together with our partners gateways to design services such as hardware, firmware, software development, and build up a one-stop shop for our customers and to bring even their solutions to the cloud services we are offering. So we are supported by many world's leading suppliers and partners to make this happen for our customers.
What role do DC and AC charging stations play? Which technologies get used where?
Well, Mustafa, I think we definitely need both. So they play different roles extending the infrastructure. Ultimately, what's better depends completely on the use cases, let's say. If you are in a need of quick recharge to continue your long distance journey, then you will definitely need a DC charging. For any other use cases, AC charging will be the way to charge your car. Some statistics mention that for every 1,000 EV on the road, we would need 3 to 4 fast charging stations and 40 public charging stations. So you see how these two are playing different roles in fulfilling the demand we have on that side. So in my eyes, when we are talking about EV and battery charging, it is not about having the full tank as we are used to it in the traditional cars we are driving now. It's about having enough power to reach the next destination.
With the 400-volt charging technologies commonly used today, high power levels come with very high current. What impact does this have on technology and charging efficiency?
Well, the technical challenges of implementing this high power can be found along the entire charging chain. So on one side, on the electric vehicle side, it's about optimizing the battery technology. So there are two things we have to take into consideration. On one side, we need batteries that they can ultra rapidly charging the battery cells required, that they are resistant to aging even with the increased charging cycles. And the second part is to improving the storage technology. It should be doubled in my eyes with the same battery size and the battery cost. There is also other side of the story, not just on the EV side, but also on the infrastructure side. We need to think about the interfaces to the infrastructure, the vehicle inlet, for example, and the infrastructure itself must also be designed for the high capacity and high charging capacity charging stations.
Many problems could be prevented with 800-volt technology. What's your assessment of that? How far along is it in its development?
Yeah, well, 800-volt architecture is already here. If we take a look at the cars, for example, we take Porsche Taycan into consideration, or Audi e-tron GT, or even Korean car manufacturers like Hyundai with Ioniq 5 model, or even Kia EV6 model, they are all based on 800-volt architecture. But the development on the car side alone is not enough. So the whole related infrastructure should get adjusted to have an effective and efficient EV experience. So of course, high voltage system will support faster charging as well as reducing thermal losses, or in other words, reducing the power losses and consequently using thinner wires and of course smaller components. So there are a lot of advantages coming up alongside with the challenges we are going to face with, but there are a lot of advantages coming with this 800-volt architecture.
Sarah, I've learned a lot about SiC and GaN during our recording sessions for our podcast. What role will these new semiconductor materials, wide bandgap materials, play in the context of fast charging in particular?
Yeah, of course, emerging wide bandgap components are prime elements for development of fast charging stations. They provide high power density, high efficiency within the compact size they have. So by implementing SiC and GaN solutions, we can reach three main advantages. First of all, we can minimize the cooling effort we have been talking about already. Second, we can deliver high power density with these technologies. And we can reduce overall system size and weight, specifically when we're talking about the onboard charging systems.
How do you think will the cost of superchargers trend in the future?
Well, charging costs for additional charging needed in each year will going to definitely decline. So this decline is due to three factors, I would say. First of all, higher utilization of chargers in terms of hours of active charging per day is going to bring kind of a better cost model to the system, definitely. Second, installation costs decline as the number of the chargers per site increases with growing market penetration. And third, we assume almost, let's say, 3% decline per charger hardware components per year. So this is going to long-term show cost decline definitely on creating and building up these charging stations.
Sarah, can manufacturers of fast charging stations benefit from product or component developments in order to bring their offerings more quickly to the market?
As an engineer, I think that a big motivation for every engineer is being faced with challenges and obstacles and finding a solution for those. So I think that, or let's say I believe, this will stay as a big driver for EV infrastructure. And the suppliers are going to have the opportunity really to going behind the limits and coming up with the different newer technologies, even maybe we don't know about it today.
What's your take on the possibility of at some point in the future that the charging of an electric car won't take significantly longer than refueling a car with an internal combustion engine today?
Yeah, well, even now today, we have technologies like ABB Terra 360 charging stations, which can add 100 kilometers of range in 3 minutes. In my eyes, what is important is really to change the mindset. I always give the example of having vegan people because they have decided to be vegan based on the benefits this is bringing to them, but still are looking for the foods that they look like meat. So there are now new products coming that they offering the vegan meat to help these people to do this switch. So I think that if we believe in the benefits of EVs, since they can help us really reducing the CO2 emission, they can help us getting independent from the fossil fuels, have a better air quality in future, I think it is a way to go. And for that, of course, we have to pay a price.
Thank you, Sarah. Thank you for giving us insights into the present and the future of fast charging infrastructure. And, it's a tradition with our show, Sarah, that I ask our participants, our guests, about when and how they developed their individual passion for technology. So how about you, Sarah? When did you become the technology geek that you are?
Yeah, when I think about it, it goes back to my childhood, Mustafa. I remember myself being 5-6 years old and being assistant of my father doing kind of reparation or washing the filter of the car, let's say, or if the radio kind of broke, we were two together opening it up and trying to understand where the problem is and eventually repair it together. So I really remember myself from those days just being involved in the technology, and the interest also comes with me. The kind of more older I get, of course, the interest is also in much more complex technologies coming to the world.
Thank you, Sarah. I vividly remember all the Walkmen that I took apart as a kid. So those memories from our childhoods, they are valuable and they've definitely been a driver. Dear listeners, please feel free to find more info in the show notes to today's episode. Please also feel free to subscribe to our podcast, Passion for Technology, on either Spotify, Apple Podcasts, or any of the other popular podcasting platforms. Thank you for joining us today, Sarah.
Thank you, Mustafa, for having me today.